So, hi, I am Rosan Aline Hawa from IT2103. So, welcome to my channel. So, from this vlog, we have to summarize what we have learned from the chapter 1 up to chapter 11. So, from the chapter 1, which is the exploring the network, first from that chapter we we are we are do some activities, which is we have to draw a concept of a internet. Then we have to what to describe that the internet. So from the chapter 1, so uh, networks and the internet have changed the way we communicate and learn, work, and even play. So network come in all sizes, so they can range from simple networks consisting of two computers to networks connecting millions of devices. So the internet is a large network in existence. In fact, the term internet means a network of networks. So the internet provides the services that enable us to connect and communicate with our families, friends, and work and interests. So internet is as we all know, we always use internet in our daily lives situation, like when we are working, when we are searching from what searching from the internet, from what we have to search or what we have to know. So the network infrastructure is the platform that supports the network. It provides the stable and reliable channel over which communication can occur. So it is made of a network components including end devices, intermediate devices, and network media. So um, network must be reliable. So this means the network must be fault tolerant, scalable, provide quality of service, and ensure security of the information and resource on the network. So network must be fault tolerant, scalable, provide quality of service, and ensure security of the information and resources on the network. So network security is an integral part of a computer networking. Regardless of whatever the network is limited to a home environment with a single connection to the internet, or the large as a corporation with thousands of users. So single solution can protect the network from the variety of threats that exist. For this reason, security should be implemented in a multiple layers using more than a security solution. So let's proceed to the chapter 2, which is configure a network operating system. So from configuring a network operating system, so uh, Cisco IOS is a term that encompasses a number of a different operating systems, so which runs upon a various network device. The technician can enter commands to configure, to program, and the devices to perform various networking functions. So the services provided by the Cisco is Cisco IOS are accessed using a command line interface, or the CLI, so which is accessed by either the console port, the AUX port, and through SSH of a telnet after connected to the CLI. So the network technician can make configuration changes to Cisco IOS devices. So the Cisco IOS is designed as a model operating system, which means a network technician must navigate through various hierarchical modes of the IOS. Each mode supports different IOS commands. So, and Cisco IOS routers and switches supports a similar model operating system, supports similar command structure, and support many of the same commands. In addition, both devices have identical initial configuration steps when implementing them in a network. So, let's proceed from the chapter 2, which is rather chapter 3. So from this chapter 3, which is uh, network protocols and communications. So from this chapter, we learn about the data networks or system of the end devices, intermediary devices, and the media connecting them. So for communicating to occur, these devices must know to communicate. So these devices must comply with the communication rules and protocols. The TCP/IP is an example of a protocol suite. So most of the protocols are created by a standard organization such as IETF or IEEE. So, the Institute of Electrical and Electronics Engineers is a professional organization for those in the electrical engineering and electronics fields. So, the ISO, the International Organization for Standardization, is the world's largest developer of international standards for a wide variety of products and services. So, from this chapter, the most widely used networking models are the OSI and the TCP/IP model. So, from associating the protocols that set rules of the data communication with the different layers of these models is useful in determining which devices and services are applied at specific points as the data passes across LANs and WANs. So, the TCP/IP protocol suite is an open standard protocol that has been endorsed by the networking industry and ratified or approved by a standard organization. The Internet Protocol Suite is a suite of protocols required for transmitting and receiving information using the Internet. So let's proceed to the next chapter, which is from this chapter 4, which is network access. So from this chapter, we've learned that the TCP and the IP network access layer is equivalent of the OSI data link layer or the layer 2 and the physical layer, layer 1. So the OS physical layer provides the means to transport the bits that make up a data link layer frame across the network media. So the physical components are the electronic hardware devices, media, and other connectors that transmit and carry the signals to represent the bits hardware components such as network adapters or NICs, interface, and connectors. So the cable materials and the cable designs are all specified in standards associated with the physical layer. The physical layer standards address three functional areas, which is the physical components, frame encoding technique, and the signaling method. And the next step is using the proper media is an important part of a network communication. Without the proper physical connection, either wired or wireless communication between any two devices will not occur. So, from this one, wired communication consists of copper media and fiber cable. So the first is that there are three main types of copper media used in networking. We have here the unshielded twisted pair or UTP, or the shielded twisted pair or STP, and the coaxial cable, which is the UTP. Cabling is the most common copper networking media. So the optical fiber cable has become very popular for interconnecting cable has become very popular infrastructure network from devices. It permits the transmission of data over longer distance and the higher bandwidth data rates than any other networking media. So unlike copper wires, fiber optic cable can transmit signals with less attenuation and completely immune to EMI and RFI. So, among the different implementation of the data link layer protocols, there are different methods of controlling access to the media. This media access control techniques define it and how the nodes and the share media, the actual media access control method just depends on the topology and the media sharing LAN and WAN topologies can physical or logical. So it is the logical topology that influences the type of a network framing and media access control use. So the ones are commonly interconnected using the point-to-point, hub and spoke or mesh physical topologies in shared media LANs. And devices can interconnected using the star, bus, ring, or extended star physical topologies. So let's proceed to the next chapter, which is this. So from chapter 5, which is Ethernet. So from this chapter, we studied about the Ethernet, which is Ethernet is the most widely used LAN technology today. So it is a family of networking technologies that are defined in the IEEE 802.2 and 802.3 standards. So an Ethernet standards define both the layer 2 protocols and the layer 1 technologies. So for the layer 2 protocols, as with all 802 IEEE standards, Ethernet relies on the two separate sublayers of the data link layer to operate. So the logical link control or LLC and the MAC sublayers. So from this chapter, uh, we have here two styles of Ethernet framing. So this is the IEEE 802.3 and the Ethernet standard and the DIX Ethernet standard, which is now referred to the Ethernet 2. So the most significant difference between the two standards is the addition of a start frame delimiter or SFD and the change of the type field up to length field in the 802.3 Ethernet 2 is the Ethernet frame format. So used in TCP/IP network as an implementation of the IEEE 802.2/3 standards, the Ethernet frame provides MAC addressing and error checking. So from this chapter, we also studied about the ARP, which is the ARP relies on certain types of Ethernet broadcast messages and Ethernet unicast message called ARP request. ARP replies the ARP protocol resolves the IPv4 addresses to MAC addresses and maintains a table of mappings. So the next one is a network layer from the chapter 6. So from this chapter, we studied about probably from network layer. So the network layer or OSI layer 3 provides services to allow end devices to exchange data. So across from the network, so to accomplish this end-to-end transport, the network layer uses four basic processes. So IP addressing for end devices encapsulation, routing, and the encapsulation. So what I've said, the encapsulation, we are capable of that two encapsulations because we tackled that from this chapter. So the internet is largely based on IPv4, which is still the most widely used network layer protocol. So an IPv4 packet contains the IP header and the payload. So however, the IPv4 has a limited number of unique public IP addresses available. This led to a development of IP version 6, IPv6. So the IPv6 is simplified header offers several advantages over IPv4, including better routing efficiency, simplified extension headers, and capability for per-flow processing. Plus, IPv6 addresses are based on the 128-bit hierarchical addressing as opposed to IPv4 and 32 bits. So this dramatically increases the number of available IP addresses. So in addition to hierarchical addressing, the network layer is also responsible for routing. So hosts require local routing table to ensure that packets are directed the correct destination network. So the local table of a host typically contains a direct connection to the local network route and the local default route. The local default route is the route to the default gateway. So the default gateway is the IP address of router interface connected to the local network when a host needs to forward the packet to a destination address that is not on the same network as the host. The packet is sent to the default gateway for further processing. So from the next chapter, which is this, So from this chapter, which is IP addressing, from the chapter 7, so we've studied all about the IP addressing. So the IP addresses are hierarchical with network, subnetwork, and host portion. So an IP address can represent a complete network as specific host or the broadcast address of the network. So understanding the binary notations is important when determining if two hosts are in the same network. So the bits within the network portion of the IP addresses must be identical for all devices that resides in the same network. So the subnet mask or the prefix is used to determine the network portion of an IP address. So the IP addresses can be assigned either statically or dynamically. So the DHCP enables the automatic assignment of an addressing information such as IP address, subnet mask, default gateway, and the other configuration information. So the IPv4 host can communicate one of the three different ways. So the unicast, broadcast, or multicast are also blocks of addresses that are used in a network that require limited or no internet access are called private addresses. So the private IPv4 address block are this. So 10.0.0.0/8, then 172.16.0/12, and 192.168.0.0.0/16. So the depletion of IPv4 address space is motivation factor for moving to IPv6. Each IPv6 address has 128 bits versus 32 bits in an IPv4 address. So the IPv6, as we all know, we have here 128 bits for IPv6. So from the IPv4, we have 32 bits. So from the IPv6, does not use as dotted or decimal subnet mask notation. The prefix length is used to indicate the network portion of an IPv6 address using the following format, which is the IPv6 address prefix length. So the next one is the subnetting IP network from chapter 8. So from the subnetting IP network, so the process of segmenting a network by dividing it into multiple smaller network spaces is called subnetting. So every network address has a valid range of a host address. Also, all devices attached to the same network will have an IPv4 host address for that network and a common subnet mask or net prefix. So traffic can be forwarded between hosts rarely if they are on the same subnet. So the traffic cannot be forwarded between subnets without the use of a router to determine if the traffic is local or remote. The router uses the subnet mask so that the prefix and the subnet mask are different ways of representing the same thing, the network portion of an address. So IPv4 subnets are created using one or more the host bits as a network bits, two very important factors that will lead to the determination of an IP address block. With the subnet mask are the number of subnets required and the maximum number of hosts needed per subnet. So there is an inverse relationship between the number of subnets and the numbers of hosts. So the more bits that are borrowed to create subnets, the fewer hosts that will available. So therefore, there are fewer hosts per subnets. So the next one is the transport layer from the chapter 9, which is the transport layer provides transport related services. So the first services related to that is dividing data received from an application into segments. So adding a header to identify the manage each segment using the header information to resemble the segment back into application data. So the passing assembled data to connect applications. So from the UDP datagrams and TCP segments have headers added in front of data that include the source port number and destination port number. So these port numbers enable data to be redirected to the correct application running on the destination computer. So the TCP does not pass any data to the network until it knows that the destination is ready to receive a TCP. So then manages the flow of the data and the resends any data segments that are not acknowledged as being received at the destination. So let's proceed to the next topic. So the next one is from application layer from the chapter 10. So from the application layer, so it is responsible for directly assessing the underlying process that manage and deliver communication to the human network. So this layer serves as the source and destination of a communication across data network. So the application layer, application services, and the protocols enable users to interact with the data network in a way that is meaningful and effective. So the application or computer programs with which the user interacts, which initiate the data transfer process, the process request. So the services are background programs that provide the connection between the application layer and the lower layers of the networking model. So the protocols provide the structure for agreed upon rules and process that ensure services running on a particular device can send and receive data from a range different network device. So delivery of the data over the network can be requested from a server by client or between devices that operate a P2P arrangement. In P2P, the client-server relationship is established according to which device's source and destination at the time messages are exchanged between the application layer services at each end device in accordance with the protocol specifications to establish and use these relationships. So, the protocols like HTTP, for example, supports the delivery of web pages to end devices, and SMTP, IMAP, and POP supports sending and receiving email. So, SMB and FTP enable users to share files in P2P applications, so make it easier for consumers to seamlessly share media in a distributed fashions. So, DNS resolves the human legible names used to refer to network resources into numeric addresses usable by the network clouds or remote upstream location that store that in all host applications so that users do not require as many local resources and so that users can seamlessly access a content on different devices from any location. Uh, the next chapter, which is the chapter 11, the last chapter. So from the last chapter, which is chapter 11, build a small network. So in order to meet our requirements, even small networks require planning and design. Planning ensures that all requirements, cost factors, and deployment options are given due consideration. And the important parts of network design is reliability, scalability, and availability. So supporting and growing a small network requires being familiar with the protocols and network applications running over the network protocols analyzers enable a network professionals to quickly compile statistical information about traffic flows. The network information gathered by the protocol analyzer is evaluated based on the source and destination of traffic as well as the type of traffic being sent. So this analysis can be used by a network technician to make a decision on how to manage the traffic more efficiently. Common network protocols include DNS, the Telnet, SMTP, POP, DHCP, HTTP, and the FTP. So it is necessity to consider security threats and vulnerabilities when planning a network implementation. So all network devices must be secure. This includes routers, switches, and end users devices, and even security devices network need to be protected from malicious software such as viruses, Trojan horse. The Worms antivirus software can detect most viruses and many Trojan horse applications and prevent them from spreading in the network. So the most effective way to mitigate our attacks is to download security updates from the operating system vendor and patch all vulnerable systems. So the network must also be protected from network attacks. So the network attacks can be classified into three major categories. It is the recognized access attacks and the denial service attacks. So there are several ways to protect a network from attacks. So the first one is authentication authorization according or AAA or AAA network security services provide the primary framework to set up the access control on the network device. So the AAA is a way to control who is permitted to access a network, authenticate what they can do while they are there, authorize and to watch the actions they perform while assessing the network accounting. So the next one is the firewall is one of the most effective security tools available for protecting internal internal network users from internal threats. So a firewall resides between two or more networks and controls the traffic between them and also helps prevent unauthorized access. So the third one is to protect network devices. So it is important to network device remotely. It is highly recommended to enable SSH instead of the unsecured telnet. So, after the network has been implemented, a network administrator must be able to monitor and maintain network connectivity. So, there are several commands available towards this end. So, for testing network connectivity to local and remote destination, commands such as ping, telnet, and traceroute are commonly used. So, on Cisco iOS device, the show version command can be used to verify a troubleshoot of the basic hardware and software components so used during the boot process to view information for all network interfaces on a router. So the show IP interface command is used to the show IP interface brief can also use to view a more abbreviated output than the show IP interface. So from Cisco Discovery Protocol CDP is a Cisco proprietary protocol that runs at the data link layer because CDP operates at the data link layer of two or more Cisco network devices, such as routers and supports different network layer protocols, can learn about each other even if layer 3 connectivity does not exist. So, as we as we do the activities from these chapters, chapter by chapters, so we do several activities like packet tracer for us to understand what is the use of the different wires, how they can connect and how to configure. So I think that's all for all of this chapter summary. So thank you for watching.